What's up, everyone? We got a little 5-minute lesson today on maybe the most important thing in the entire geometry curriculum, and that is sine, cosine, and tangent. You've been working hard to get here. You went back over the Pythagorean theorem, which is the foundation of right triangle trigonometry. You have learned all about similar triangles, which is why this actually works. And now I'm going to try to help you understand the functions so that you can use this. They used to call the next class after Algebra 2 trig, short for what? Trigonometry, which stands for the study of triangles. And now that class has been rebranded as pre-calc. So like I could make a 10-hour video on this. It has a whole class based on it. Most of your physics class uses math from this, okay? And this is why I'm trying to bring it up to you that it is indeed a big deal. These are the rules for the functions sine, cosine, and tangent. You are going to shorthand. Remember this as SOH CAH TOA. What this is a way to remember which sides go with which function. So the sine is equal to the opposite divided by the hypotenuse. The cosine is equal to the adjacent divided by the hypotenuse. And the tangent is equal to the opposite over adjacent. Okay, your parents learned about SOH CAH TOA. My math teacher, I think he passed away just last year, but I had the same math teacher all 4 years of high school, which was rough because he was difficult. But he used to teach us some old hippie caught another hippie taking our acid. Swear to God, that's how he taught it to us. Okay, and he was a man of the cloth, like he was a priest, but that's how he taught us to remember it. If you have a good way to remember SOH CAH TOA, spread it to your friends, make your own little sentence up, but you absolutely need to remember this. Okay. Boink. I guess one thing I want to remind you is really you should write it like this. Sine of an angle is equal to the opposite side over the hypotenuse side. Take another look at this. There are 3 variables. You have your angle. That changes. You have your opposite side. What you've learned this year is as your angle gets bigger, do this with your hands. As your angle gets bigger, the side opposite of that angle gets bigger, right? And then this, your hypotenuse, is always across from the right angle. It's always the longest side of your right triangle. Next, come on. All right, how does this work? It's easiest for me to start with a triangle and a function that you might be familiar with, okay? Okay, so this might be how many of your basic problems start. So these are the questions you ask yourself. According to the angle that I'm given, what is the x? Is it opposite from that angle? Is it adjacent from that angle? Or is it the hypotenuse? It's the opposite, okay? What is the 12? It's the adjacent. Now, which function from before uses opposite and adjacent? Tangents. So now we say tangent of our angle is opposite divided by adjacent. I recommend you just start by writing that out every question, and that'll help you remember it. What is our angle? 45. Our opposite is x, and our adjacent is 12. Okay? Now, tangent of 45 is a number. Every single one of these numbers has been put into your calculator. Okay? Now, I chose 45 because it's the only one that gives you a nice, well, it's not the only one, but it's one of the only ones that gives you a nice even number, okay? So now watch, I go Well, hold on. This is in radians. If you're using a graphing calculator, you're going to have to go to mode and switch it to degrees. I forgot this is why I was pulling this up. Okay? And so now I say tangent of 45. And look what that gives me. Uh-oh, I'm still in radians. I have to hit enter. Mode. Enter. It didn't take my enter. Quit. Now watch. When I go tangent of 45, it's going to give me a totally different number. Because a radian is a different measurement than a degree, and we're going to get into all that. Okay? So tangent of 45 is 1. From here on out, I'm just going to ask you guys to come up with that, to put that in your calculator for me, so someone can have a calculator ready, because obviously it's going to erase it every time. So tangent of 45 is x over 12. What do we say the tangent of 45 was? 1 equals x over 12. I can put that over 1. Multiply both sides by 12, and you get x is 12. Doesn't that make sense? Because what kind of triangle was it? It was a 45, 45, 90. So you knew that those were the same. Okay? Let me go big, and let's do another example. It's going to be longer than 5 minutes for sure, but it's my video. Do whatever I want. So how it works is that your calculator has a huge chart typed into it. So now let's imagine that's a 10-degree angle. And this is still 12. And we want to find this. Okay? First of all, take a guess. Is x going to be more than 12 or less than 12? Definitely more. Not because of the way I drove my triangle, but if that's 10, then this is 80. So I'm expecting x to be significantly larger than 12. Okay, according to the 10, what is the 12? Is it opposite, adjacent, or hypotenuse? Opposite. What's the x?
Adjacent.
Adjacent. So we say tangent of 10 is 12 over x. You might want to put this over 1 right away. Set up a proportion. We've been doing a lot of proportions. Can somebody give me the tangent of 10 to 5 decimal places?
.1762.
That's what the tangent of 10 is. Here's what this means. That means that this side is like 17% of that side. The triangles can be as big or small as we want. But what the tangent of 10 tells us is the ratio between the opposite and the hypotenuse. So now when we solve this, you get 0.17632 times x equals 12 times 1. So Isaac, can you do 12 divided by 0.17632? Or if you're working in a graphing calculator, it's even more accurate to just do 12 divided by the tangent of 10. But what do you get for that, Isaac?
How many decimal places?
I don't care.
68.058.
So I'll call it 68.06. Now look at the difference. So this function is taking the fact that all triangles are similar. I'm going to pause this real quick. So it's just saying that we know the ratio of any of the triangles. As long as we know one side, we can find all the missing parts. Okay? A couple more slides. If it's a special right triangle, this is the only time where they might ask you to get the answers exact. So like, there's 2 ways to do the special right triangle. If you forget way 1, then just use the other way. I'm drawing you an intentionally misleading triangle there. So let's say I wanted to use special right triangles to do this. What's the missing angle right here? It's 60. Okay. So we have 30, 60, 90 triangles. We have a short leg is 1, the long leg is radical 3, and the hypotenuse is 2. Is X our short leg or our long leg in that yellow picture? It's our short leg. So how do I get from our hypotenuse to our short leg? Divide by 2. The fast way is that X equals 6. Now, let's see how we can do it using SOH CAH TOA. According to the 30, what is the X? Is it opposite, adjacent, or hypotenuse? It's opposite. What's the 12? Hypotenuse. Do you remember which one involves opposite and hypotenuse? That's going to be sine. Very good. Okay. So sine of 30 equals X over 12. Put sine of 30 in your calculator and watch what you're going to get. You get 0.5. That's telling you that it's half the hypotenuse. Okay? And so you multiply both sides by 12 and you get X equals 6. So look, there's 2 ways you can do that now. Okay? What if it wasn't a special right triangle? We went over one of those, but let's do one with a cosine. So let's say I had an upside down right triangle. Harper, make up a number that you think that angle could be. What do you think? 37. Okay, I'm good with that. And let's say that the hypotenuse is 26 inches. And this is, no, we wanted to use cosine, excuse me. Well, let's say we wanted to find X, and this was Y. Solve for X. According to our angle 37, which side is our X? Is it opposite, adjacent, or hypotenuse? Adjacent. What about the side we know, the 26? That's the hypotenuse, so that's the adjacent. That side's the hypotenuse. That's going to be cosine of 37 is X over 26. So we can solve these with proportions, or we can just multiply both sides by 26. Isaac, will you do 26 times the cosine of 37?
20.764.
20.76. Does that answer make sense to you? You can always check these. It's smaller than the hypotenuse. Now, if we wanted to find y, there's 2 good ways to find y now. What would be one of those ways? We can use sine, or we can use Pythag. I would just use Pythagorean theorem. Once you have 2 of your 3 sides, go back to Pythagorean theorem. Okay, almost done with this lengthy video. I just have to show you how to find an angle. More right triangles. These will always be right triangles, and then we'll get into long sines and cosines later, which will not involve right triangles. Let's say this is X, and this is, no, hold on, it can't be X. Let's say, I forgot we were trying to find an angle. That was 13, that was 14, and that's what you wanted to find. Which side is bigger, 13 or 14? 14. So I think X is going to be less than 45 degrees. It's important you have a sense for what your answer might be. And I think this one over here, I think Y is going to be slightly bigger than 45 degrees. Okay, we're trying to find X. According to the X, what is the 13? And what is the 14? And which one involves opposite and adjacent? So you say tangent of, now what has always gone in that parentheses? The angle. What's our angle?
X.
It's X. Now, as I stated before, these things are functions. So every function has an inverse function. It has to. What's the inverse of multiplication? Division. What's the inverse of squaring? Square root. They don't have a very good name for this, but it is right there on your calculator, and this is a super important part of the video. If you're going to find an angle, you've got to hit the second key on your calculator. You've got to hit the blue key, because I need to do the tangent inverse. That is the inverse function for tangent. So when you do tangent inverse of tangent, they cancel each other. And you get x is the tangent inverse of 13/14. So in your calculator, hit second tangent, 13 divided by 14, close, enter. What do you get, Isaac?
42.878.
42.88 degrees. Does that answer make you feel confident? We expected it to be a little less than 45. That would have made angle Y like what, 47.22? We're doing good, okay? That's all I can expect you guys to listen to at this point. Boom!